so thanks for having me here. Thanks for coming to this nice place today. This will be about rethinking data access with the HTTP resource. And if you think about your application in general, then quite often you think about your application in terms of a script, like when playing theater. A script that tells you what to do and when to do it. Step by step, you just go through this script. It tells you do this, do that, say this, say that, act like this, act like that. And this is completely fine. However, when we want to switch over to reactive programming, and if we do signals, if we do the resource, we need to switch over to reactive programming. We need to think differently about our application. We need to think more about it as a marble, where several marbles go through, and those marbles represent your data. The data that goes through your application. And here, those marbles are your data items. And sometimes those marbles can be merged together to one marble. Sometimes they can be split to several marbles. So it's more a data-centric view. You can also say you're looking more at the data flow than at the control flow, like with the script. Funnily, sometimes a marble comes out there at the end, and this is something you are usually displaying to the user by data binding. Usually we are using data binding for this because this is how Angular works. Sometimes we need something else if you need to call a method in order to display something, but in most cases, data binding is your friend. And this is what mainly this talk is about. Even though it's also a lot about the HTTP resource, it's mainly about switching our thinking into this very direction. This really helps you to succeed with reactive programming. So what's the agenda like? I want to get started with the signal graph, which is the official technical way to express what I have expressed with the metaphor of a marble run. The signal graph is real. It exists in your Angular application. Then we will go on with the HTTP resource, and we will see how we can use it in the middle of our signal graph. We will proceed with a little tiny demonstration, and then we will go on with discovering the signal graph that is made up of HTTP resources in our demonstration. And this leads to some live coding. Before we start, let me introduce myself. I'm Manfred. I'm a trainer and consultant for Angular, and I'm focusing on Angular in the enterprise. In this role, I'm helping a lot of companies with trainings, with consulting, with reviews. We are visiting a lot of companies and doing our stuff there. Besides this, I'm also quite connected to the Angular community. I live in Austria. This is where my accent comes from. But I also do a lot of stuff in Germany. You know, the big brother of Austria, Germany. I'm there on a regular basis every second week. And I'm always happy to work together with people around the globe. For instance, it was a pleasure for me to come here to Nantes for the first time. Okay, so let's talk about the signal graph. And for this, I have a first simple example, a very tasty one, if you ask me. It's about desserts. I already told Jerome today, dessert is my most favorite French term. I really love it. So, and here I have not only desserts, but I have also ratings for desserts. Both are represented by signals. And then I have a computed signal that is merging the ratings into my desserts. Because usually I want to display my desserts with some stars. A 5-star rating here, a 4-star rating there, for instance. And this is done with computed. So this now can be seen as some kind of simple marble run. This is already a reactive graph. Namely, you have this purple marble, you have the pink marble, and both marbles go into the computed where the rated desserts are computed. And so we are getting out another marble, the rated desert marble that is proceeding in our marble run, in our data flow, in our reactive graph. However, there is a little tiny issue, because I was cheating now a bit. I just told you about the good side of the marble run. However, there is another side, a very tiny marble run that is not connected in a reactive way to the remaining parts, namely my search criteria. I want to search using the original name, the original German name, France name, and so on, or the English name. So those are my search criteria, and currently they are not connected. So here, where we have this arrow, a wonder happens. And funnily, before Angular 19, there was no official way of bridging this gap in the signal world. Of course, we could have always transitioned over to RxJS. There is an interop solution to convert signals to RxJS observables, and then we can go on with smidge map and merge map and so on. But there was no official signal-based way for doing this. And that's why I was really happy that with Angular 19, we got the resource API. The resource API that allows us exactly to bridge this gap in the world of signals. So how does this look like? Well, in the world of the resource API, you have this low-level construct called the resource. And you see here, it takes parameters. And those parameters are just a signal. And every time the signal is changing, a loader is triggered. The loader also gets some parameters, which has the parameters from before. So here we have params. We've discussed this some days ago. It's a very symmetric API, if you ask me. But I'm not sure if this is what people refer to when they are talking about symmetric APIs. But nevertheless, here I'm getting my criteria from above, my desert criteria, and I can use it to fetch some data. On this low level, we are using promises. Nevertheless, you always have switch map semantics. And on higher levels, you can use something differently, like RxJS observables. And now I have a complete marble run. Here I have my resource. Here I have my marbles, original name and English name, go into desert criteria. Desert criteria, the next marble is going into my desert's resource. And then the next marble, the pink one, is coming out. A resource has a value that informs us about what we have fetched in terms of data. And it's our deserts array that one more time goes here into my computed, where the ratings are added to it. So here you see a complete marble run. However, the thing is, usually you don't want to work on this low level with promises. Usually you want to work on a higher abstraction level, like with observables. For this, we have an Rx resource. Or, and this is new with Angular, with the HTTP resource that is basically doing an HTTP request. You pass in an URL. You pass in some parameters in terms of signals. And one more time, every time those signals are changing, the resource is triggered. And so it will fetch some data from the backend. And as mentioned before, this results in our value marble that flows into computed, where it is combined with the ratings. And for this, I've prepared a little tiny demonstration. This little tiny demonstration is a throwback to my childhood. Let me quickly start it. NG serve. It's about Super Mario. Who knows Super Mario? Yeah, of course, everyone. So what I did here is, it's currently, oh, it's the wrong display. Now we are talking. Super Mario. So it is basically rendering a level of Super Mario. I can give it a level description in terms of JSON. There is a tiles map. and then you can even toggle through all the levels. So it's really funny, and trust me, it was a lot of fun implementing this. It took me some days, but it was a lot of fun, and my 9-year-old son was sitting next to me and looking with big eyes at my screen. He told me, and now let's make Super Mario this and that and Kickbox browser. And I had to tell him, well, it's not that easy. But very interestingly, in Super Mario, there are 4 themes. And usually one level is connected to one theme. However, in theory, we can switch the themes for each and every level. We could say, well, let's use for this not overworld, but underground. And then it looks like this. Or let's use the underwater theme, then it would look like that, or the castle theme. And I can even switch between my levels and scroll across them. So I guess you know the sound. Awesome. So if we look at the implementation of all of this, the heart of this implementation is an asset, namely this tiles map here. So look at this. There are several tiles there, tiles in different themes. By the way, I've borrowed this from the internet, and those themes are located to each other. So if I know the coordinates of this floor tile, I just need to add an offset to switch the theme to the underground theme or to the underwater theme. Just add something to the X or epsilon coordinates, and the same for all the other things. Besides this, I have a level overview. It just informs me about the levels I've implemented. And I have this level description that tells me, well, the first level starts with the floor tail, and it starts at coordinate 0, 13. So if we look here, 0, 13 is here, and then it will repeat it 55 times from left to right and 2 times from bottom to top. So this is what we see here, 55 times from left to right and 2 times from top to bottom. And this allows you to completely freely design your very own levels. And if you feel funny, you can also add a level, a level designer for doing this in a more graphical way, which might be another feature in the future. Let's see. Okay, so this is what I'm doing in there. Now, let's talk about the reactive graph of this application. If we look at this application from the perspective of a reactive graph, first of all, we see 3 signals. There is one signal for we are allowed to modify. The level key informs us about the selected level, in my case, level 1 or 2. The style informs us about the theme we have selected, overworld or underground, and the animation is a Boolean telling us whether the animation is on or off. There is another signal that gives us a canvas, because we need to paint somewhere our tiles, our levels. For this, we have the canvas. And in there, we also have a tiles progress map, tiles map progress, which is also a signal telling us how much of the tiles map has been loaded, 10%, 20%, and so on. So those are more or less nodes in the outer areas of our graph. But somehow, those nodes need to be connected to each other to form a graph. And for this, I'm going with resources, mainly with HTTP resources. There is a level resource that is loading the current level description. This style here, that style there. There is a tiles map resource loading the entire tiles map we have seen before, and it informs us about the progress. There is a tiles resource. This is a funny one. This is a traditional resource that takes the result of the tiles map, all the tiles. It takes the style, the theme, and then it extracts the tiles we need for this theme. Like now, this is your floor theme, your floor tile with the underground theme, or this is your brick style with the underground theme, stuff like this. And in the middle, we have an effect. an effect that is connecting all the dots and rendering something out to the canvas. As mentioned before, usually you don't use effects. Usually you use data binding for stuff like this. However, in this special case, I cannot use data binding to draw on a canvas. And so the effect is here really an ideal typical solution. So whilst most of the times it's the wrong solution, here we have an ideal typical solution. We need to execute some commands to get the tiles on our canvas. Okay, and now, oh yeah, by the way, as an entry track, there is a level overview resource, but it's not doing much. It just gives you the level overview, informing you have 2 levels. Now let's discover this reactive graph in our application. And for this, let's get started with the level loader. So in there, we have several methods returning a resource. This is usually how I would use resources. I would create a factory function for them, because usually when constructing your reactive graph, you're not interested into the little tiny nitty-gritty details of your resource. Hence, I'm hiding the construction behind methods. For instance, here, we have a level overview resource, which is just a HTTP resource, returning our level overview. And that is very important, meanwhile, we can also define a default value. This is important because before we have fetched some data, usually the resource would start with undefined. And we all know working with undefined and null values is not fun at all. You have to do those ifs, you have to make sure there is no issue, no null pointer exception, stuff like this. That's why I'm really happy about this default value, because even an object with an empty array is far better than undefined. By the way, you always need a lambda expression. In the first version of the resource API that came with Angular 19, the lambda expression was optional. Meanwhile, with Angular 20, you have to go with a lambda expression because the resource will tinker a computed signal out of this. The resource wants to know when something in there is changing. Well, here nothing might change because it's just a static string. However, if you look there at getLabel resource, some stuff can change. We have here a string, and as part of the string, we have the label key. We have the value of our label key signal. And whenever this signal is changing, we want to fetch the next level. That's why we need here this lambda expression. By the way, people are always wondering how to tell the resource to not fetch a thing. Perhaps you don't want to fetch something in the beginning. By default, the resource is quite busy. It comes to this world and starts fetching, you know. It acts like the Duracell rabbit back then in the advertisement. But if you don't want the resource to fetch anything, you just need to return undefined. This is the official way. Here I'm doing it with the ternary operator, but if it is a bit more complicated, I would go with a nice if that is checking the conditions, and if everything is right, I'm returning something. If I don't want to load data because I have not selected a label yet, then I return undefined. Also here, we have a default value, which is important. Otherwise, we would start with undefined. And this is quite nice. There is a parse method. You can define a parse, let's call it function. It's not really a method in that sense. It's a parse function. Originally, it was called map. And so my first idea was, well, this is like map in RxJS. And yes, it's kind of that, but it's for a very specific purpose. Who knows the reviver in JSON.parse? Who has seen this reviver function? It's not that known. One person has seen it. So it basically allows you to parse the JSON by hand and to bring it back to life, for instance, by exchanging strings with dates by date objects, or by exchanging strings with coordinates by coordinate objects. And this is what we can do here. We can parse the raw value we got from the backend. We can check if everything is right in there, if the structure is what we expect. Perhaps you don't trust your backend. You want to make sure that you get the right format from the backend. You can check it in there. And you can revive your properties. I've used this recently to revive dates, because if we talk about JSON, you just can transmit strings with ISO strings, yeah. And in this case, I wanted to have real date objects in the front end again. So usually you use something like SOT for this, which allows you to define schemes for your data objects. In my case, I've done it by hand just for the purpose of demonstration. Don't do this at home. It's just for the purpose of demonstration. I just wanted to show how you work in there and that you get a raw representation of the data as unknown, and then you can do your thing to make sure it's the right format and everything is revived. Okay, so besides those things, there is another overload of the HTTP resource. You see it here. If you want to define more than just an URL, and I guess in most cases you really want to define more than just an URL, you can return here a lambda expression with a whole object. And in there you have your URL, you have headers, you have URL parameters that are added to the end of your URL, and you have information like, do you want to report the progress? Do you want to know that you have downloaded 10% of this file, 20% of this file, 50% of this file? And we also have the other stuff we already know from the HTTP client, which is not a coincidence because the current implementation is using the HTTP client underneath the covers. That's why also stuff like interceptors will work here. There is one important thing, namely, usually you go with get, because the resource is mainly for fetching data. It's not intended for updating data. And even though you can switch get to post and put then something else. Don't do it lightly, because usually you don't use post for fetching data. But if the backend people force you to do something like this, then this API got you covered. Otherwise, I would not even mention that you can switch the method or that you can define a payload that is transferred. Okay, this is the level loader. Besides this, I have a tiles map loader. And here the tiles map loader is just returning a blob. And this is also quite funny here in the HTTP resource because it's a function. But as we all know, a function in JavaScript is an object, and an object can have methods, and blob is one of those methods to just fetch a blob. Besides this, we also have array buffer to fetch an, array buffer, or .text if you want to fetch something in plain text, for instance, XML, or if you don't feel any pain, edifact or something like this, some flat map files, but usually we don't have to do this. Here I'm going with a blob. I want to load my tiles map, and I want to report the progress. This gives me a progress signal that informs me that 10%, 20%, 30% of this huge map has been loaded. I mean, in this case, it's more for the sake of demonstration. But imagine a 3D game where you have to load a lot of models and textures. There, something like this would come in handy. One last thing. There is another factory function. Where is it? Create tiles resource. This is just an ordinary resource. I don't want to spend that much time on it. This is just an ordinary resource that is just calling one of my one of my functions from the rendering engine. This function gets the whole tile map, it gets the style, overworld, underground, undersea, something like this, and then it extracts the right tiles. And for this, I'm passing in, you see it here, the tiles map resource and a signal. This is just a very abstract way to define a signal. It's basically its scatter that returns the style. And now let's come, and please give me 3 additional minutes to finish this. I know I'm already a bit over time. Now let's come to the interesting point of this, where all of this comes together. This is here. Now here we see the first time our reactive graph, and this is what all reactive programming is about in the source code. We see there is a signal for the label key, which is a linked signal. There is a signal for the style and for the animation. We see I'm creating my tiles map resource. It's one of the methods I've discussed with you. I'm creating the label resource. It gets the signal with the label key. And every time this signal is changing, it will be triggered. And so it will load the next level description. Here I'm loading the label overview with a resource. Here I'm loading my tiles with my very own resource, taking the tiles map, taking my style signal, merging it together, and delegating to my rendering API. And here we see we are also deriving the progress of loading the tiles map. Besides this, here we have this effect. And this effect takes everything we need for painting stuff on the canvas. And as you know, as we are reading in here signals, the effect will automatically rerun when one of those signals is changing. Usually you do this with data binding, but here we need the effect to tell our rendering engine to animate a level or to just render a level. And this ends up with the result we have seen in there. So let me come to a conclusion. What did we see today? Basically, we have seen it's all about the reactive graph. You need to think in terms of this reactive graph to succeed. And trust me, it's really that way. Because originally, when I saw signals for the first time, I thought, well, that's really nice. I have objects with gathers and setters, and that's it. But no, that's not it. You need to switch your thinking. And usually, you can build a graph with computed if you want to derive data in a synchronous way. With the linked signal, if you want to derive it also in a synchronous way, but this gives you write-able data, data with a working copy. And the resource API can be used to derive data in an asynchronous way. Fetching data from the backend is the best example, if you ask me. And by the way, the value in there is writable. You get a local working copy for CRUD scenarios, for instance. So you need to build your reactive graph with those 3 elements. We have the HTTP resource for fetching data. Usually you hide the creation of resources behind methods. You are not interested into the nitty-gritty details. And there is a last thing I wanted to remember, namely, think about your source code in terms of a marble run. And that's it. So thanks for having me. By the way, I've already uploaded my examples and slides to my blog. You'll find it here, and feel free to follow me on social media to stay in contact. Thank you.